Okay, let's construct the Lewis structure for H2O2, hydrogen peroxide. This equation right here, number of bonds, will let us know how many bonds this molecule should contain. The electron demand is how many electrons each of these atoms like to be surrounded by to have a noble gas configuration. We know oxygen has the octet rule, but hydrogen has a duet rule because it likes to be like helium, so it only like to be 2 electrons surrounding it. And these like to follow the octet rule, so they want 8 electrons surrounding it. So if we add that all up, 8 plus 8 is 16, 16 plus 2 is 20. So clean that up. 20 minus the supply. The supply is where we look at the periodic table, how many valence electrons each of these atoms contribute to the molecule. So hydrogen is found in group 1, so that is 1 valence electron. Oxygen is found in group 16, and that contributes 6 valence electrons, so once again found in group 16, so 6 valence. Hydrogen is found in group 1, that's 1 valence. So let's add all these up. 6 plus 6 is 12, 13, 14. So clean that up. That's minus 14. 20 minus 14 is 6 divided by 2, and that gives us 3. So where are we going to place these 3 bonds? Well, we know hydrogen and oxygen will have a single bond because it will satisfy hydrogen, the duet rule, to be like helium. So we'll give them single bonds. Now we have 2 bonds given, and we had 3 to give, but we've given 2, so 3 minus 2 is 1. So we only have 1 bond left to give, so we have to put it here. So they all have single bonds. Now let's fill in the remaining electrons to give octets. There we go. So we count them up, 2, 4, 6, 8, 10, 12, 14, which was our supply, so that checks out. Now let's do the formal charge. So how many valence electrons does hydrogen have? It has 1, minus the non-bonding, which is 0 because there's no lone pairs on there, plus number of bonds. It has a single bond, so that's 1, so that equals 0. This hydrogen is the same setup, it only has a single bond, so we can just say that's 0. And these oxygens are the same too, so we only have to do really 1 oxygen. So oxygen has 6 valence minus the non-bonding, which is 1, 2, 3, 4, plus the number of bonds. It has a single bond, 2 of them, 2 single bonds, so that's plus 2. So 6 minus 6 equals 0. So that's the same thing for this one, so it'll be 0 because it has 2 lone pairs and 2 single bonds. That'll just save time. So yeah, that is your Lewis structure for hydrogen peroxide. Hope this video helped.